This week on the show, we read FreeBSD's third quarterly status report a little bit closer. Then we have an article about OpenBSD on SPARC 64. The ZFS on Linux repo gets renamed to OpenZFS repo to be the one true repo. Then we have an article about the GEOM NOP utility and what it can do. We also cover a little bit about keeping NetBSD up to date in modern days and times, and more in this week's episode of BSD Now. BSD Now, episode 327, ZFS Rename Repo. Recorded for the 4th of December 2019. Hello, I'm your host, Benedikt Kreuzling.
And I'm Alan Jude.
Thank you for tuning in this week, whether you're on the road or at home listening to us. We have the greatest headlines, as always, for you from the BSD world, starting with the FreeBSD third quarterly status report.
Yeah, so this is a big report of basically everything done since the summer into the fall of 2019. And so there's reports from a bunch of the teams, including the cluster admin team, the continuous integration team, the core team, the foundation, the new graphics team that manages the drivers for laptops and so on, the release engineering team, and the security team. And then there are many projects that have been done to do interesting things. Work in the kernel, work on architectures, userland, ports, and so on.
Mm-hmm. That gives an overview of what people are working on, what is still left to be done, and sometimes where you can help. So it's good to start reading that.
So the cluster admin team worked on improvements to sites in Taiwan and Japan, retired the old site at Yahoo. Now that Yahoo is, I think they're moving out of the building that we were in and are leasing it to Google or something. I don't remember the details. But anyway, we... FreeBSD.org hosted a large portion of the project there from the year 2000 to about 2019. So almost 20 years of stuff has been served out of Yahoo for FreeBSD. We also installed some new machines for Port Manager, donated by the FreeBSD Foundation or funded by the FreeBSD Foundation and your donations to continue to build packages as quickly as possible. Worked on helping UQS, who manages the GitHub exporter for FreeBSD, and solved some problems with that. And worked on getting some Power 8 and Power 9 machines online to be used as package builders and reference hosts, which allow FreeBSD developers to have access to a machine that, they wouldn't have at home, but to be able to test their changes and so on the PowerPC 64 architecture.
That's good to have.
Plus lots more work in progress, including setting up a mirror in South Africa, solving more issues with the Power 9 machines, upgrading some of the package builders to use SSDs to get better performance, and solving issues with the ARM64 boot machines, and managing a new donated co-location space that's coming up in Chicago.
Ah, okay. More locations around the world coming up.
Then the continuous integration team worked on a list of things. They have some links to their work in progress and HackMD stuff from that. And they also have started issuing weekly reports. So you can actually see the health of the continuous integration tests in FreeBSD over time, which is quite interesting. They've also been trying out using a pull request model on the FreeBSD-CI repo on GitHub.
Oh, yeah.
Then the FreeBSD core team had their report, included provisionally accepting the BSD plus patent license on per instance basis for some code. So some stuff that's licensed under the BSD license, but with an addendum about patents. And you can read more about that in the links there. We also established a new kernel pseudo random number generator maintainership rules, which allow some committers who work on this regularly to have a less onerous process to get their commits approved, and to try to keep FreeBSD well maintained in that area. And we also approved some new commit bits, including one for Pavel Bernanke, who's being mentored by Konstantin and Matthias.
Cool.
And Core kicked off the Git transition working group, and they've had a number of meetings now. and they're starting to actually have their own reports. So I imagine in the next quarterly status report, there will be one from that team as well.
So we stay tuned a little longer to see what's happening there.
Yeah. Then the foundation has a big update, similar to the monthly updates that they send out, just batched up here. But reminder that they're setting up the FreeBSD miniconf at linux.conf.au in the Gold Coast in Australia. So they're looking for more speakers and just more people to talk about FreeBSD.
In general, all the activities that we did in that quarter are listed there. That's quite a lot. That's why we don't read it all. So it's definitely worth a visit. And since we're already into the FreeBSD Foundation, we're already looking for the donations because the year is kind of drawing into an end. So if you have some money left, then we would be happy if you donate that to us and to enable some of the things we listed here, like machines, or people can travel to conferences and things like that. That's good work that the foundation does here. Okay, back to the report. The graphics team status report reads interesting. So they write that the FreeBSD X11 graphics team in general maintains the lower levels of the FreeBSD graphics stack, which includes the graphics drivers, the graphics libraries, such as the Mesa OpenGL implementation, the Xorg server with related libs and applications, and a Wayland with related libraries and applications. So that's still oncoming. But still at this point, they're having to maintain both. And so that's the job of their team. So during the last period, between this report and the last, several changes have been made. Most of them have been behind the scenes. They have been worked on, in general, on cleanups of old Xorg ports that have been deprecated upstream, so we don't need to maintain those anymore. And so the ports infrastructure for Xorg ports that depend on Xorgs have been updated. They have switched the use_Xorg and the Xorg_cat to use uses framework that's in the ports collection, instead of the old way of including the bsd.xorg.mk from bsd.port.mk. So this infrastructure work has been fairly substantial, and new ports depending on the Xorg ports should add the uses equals Xorg to their make files, and that will help their team pull these framework bits in more easily. They also have worked on cleanup and deprecation of several old Xorg ports, as they wrote. They have been removed in most cases, and some are still waiting for removal after a sufficient deprecation period because some people still use some of the older stuff. Most notably among them are the X11/lib capital X and then lowercase p, which requires to fix several dependencies, and several of the old libraries have been deprecated, such as like XXF86MISC and the lib. Oh, there's a font here. It's an X11 fonts, libx font cache, and graphics/libglw are also deprecated. And so some of the applications have already been deprecated during this period, and the remaining removals in this area, they should be up to speed with deprecating those upstreams as well. Okay, so this is also, like, people are always expecting, there's new stuff coming and features are getting added, but it's also like removing some of the old stuff so that the path is cleared forward and we don't have to maintain some of the old cruft lying around anymore. So that's also important for the team. Then there's news from the FreeBSD release engineering team. These are the people who provides the among other things, the ISOs for you with new releases. And they report that during the third quarter of 2019, they have finished the 11.3 release cycle, with the final release build started on July 5th and the official announcement sent on July 9th. So that is out there, and you probably have this already if you're on the 11 branch. And FreeBSD 11.3 is the fourth release of the stable 11 branch, building on the stability and reliability of 11.2. They also started the work on the now released, in this case, upcoming 12.1 release. That started on September 6th, and this was the first freezeless release from the Subversion repo, and a testbed for eliminating some of the requirements of a hard code freeze on development branches. So I think that was a successful test, and I guess future minor releases will also use this approach. They report mostly about the 12.1 release cycle, which is done by now. So that's good work there. And Some of this work actually was sponsored by Rubicon Communications, i.e. Netgate, and some of it was also done by the FreeBSD Foundation. Then there's news from the security team. Since June, they have started having fortnightly conference calls to discuss important issues and to collaborate closely on advisories and errata notices in the pipeline. And so that's more team coordination internally. But there's also work being done on errata notices. So they have sent out 7 security advisories in the third quarter and errata notices 5. So that's already out, and you should have them by now.
Well, yeah, these ones would be months old now.
Yeah, and you should apply them if they are security related.
Quickly under projects, the FAT, or File Allocation Table, or MS-DOS-FS support in MakeFS. Ed Maas worked on this. He says, in order to streamline the process of creating and installing virtual machine images and to create the EFI system partition stuff, the FAT file system support in MakeFS was something we desired. So MakeFS was originally developed in NetBSD, and FAT support was added there at some point after FreeBSD imported it and was missing on FreeBSD. So what MakeFS does is allows you as a non-root user in order to make a file system image. So instead of, if you're root on your machine, you can create a memory disk backed by a file and then use all the regular tools to create the file system. And now you have a file system in a file. But if you're not root, you can't go creating memory disks and stuff. So MakeFS allows you to actually just say, hey, take all the stuff in this directory and put it in this disk image by formatting it with this file system. And it supports a bunch of file systems, but didn't support MS-DOS-FS, but now it does. So the original work was done by Siva Mahadevan, who is the FreeBSD Foundation's intern from the University of Waterloo last summer, I think. And worked on porting that FAT support from NetBSD. And then Ed rebased that and updated it and committed it during that quarter. After a few follow-up fixes, we're able to build FAT file systems without needing a memory disk device and without the requirement to be the root user.
Oh.
And that project was sponsored by the FreeBSD Foundation. Next up, Fuse. So that's file systems in user space. Alan Summers worked on updating that. So he says, Fuse, or File Systems in User Space, allows a user space program to implement a file system. It is widely used to support out-of-tree file systems like NTFS, as well as exotic pseudo-file systems like SSHFS. FreeBSD's Fuse driver was based on a Google Summer of Code project in 2010, which was then, I think, imported by George Neville Neal. And then since that time, it's largely not been touched. The Fuse software itself was buggy and out of date, and our implementation was about 11 years behind the standard. So during Q3, Alan Summers worked under sponsorship by the FreeBSD Foundation to update it. He fixed a few newly introduced bugs, fixed some long-standing send file bugs that affected Fuse, and he has the bug numbers in there. And merged everything to head and to the stable 12 branch, I think in time for it would be part of 12.1. Then I fixed the resulting coverity issues that were uncovered. There have been no new Fuse-related bug reports in the meantime, so I can only assume that everything is working perfectly. If you have any problems, you can file them in Bugzilla and email asummers@freebsd.org.
Okay.
Then we have the output of our Google Summer of Code. So the FreeBSD project participated in Google Summer of Code 2019, making our 14th year of participation. And there were 6 successful projects this year, including making a dual stack ping command. So instead of having ping and ping 6, we're separate for IPv4 and v6. We now have a single ping command that can do both. Asan Barkati worked on the firewall test suite, which is a system for automatically testing firewalls, which has found a number of bugs and been generally very useful. Hostin Karabas worked on the kernel sanitizers, and Shavank Garg worked on a very interesting MAC policy framework for IP addresses in FreeBSD jails. So when you create a vimage jail, the user gets a network card, and unlike in a regular jail where when you create the jail, you assign it the IPs, say you can use these IPs that also exist on the host. In a vimage jail, the user can assign their own IPs, which leads to the situation where they could assign IPs they shouldn't and create IP conflicts or just snoop on your network and all kinds of bad things they could do. So this new Mac policy plugin will allow you to say, this jail is only allowed to use this IP address or this list or this range, allowing you to lock down those vMimage jails so they can only have the IP addresses that are what they're supposed to have.
Cool.
And prevent them from snooping on traffic or, maliciously breaking your network. And then Theron Tarago worked on the separation of the ports build process from the local installation, further making it so that compiling the ports and stuff doesn't actually cause impact on what's running on your computer. And so, building a new version of the package shouldn't affect what's installed on your laptop. And previously it did. And then lastly, I hadn't seen this one, Paavo Ennari Kapali worked on virtual memory compression. So this is actually compressing data when storing it in memory to basically fit more data in memory. Gonna have to look into that one. But big thank you to Google for the opportunity to work with these students and to all the students for completing their projects.
Yes, that's always good to get the students working on something and also being part of the project, and maybe they will continue after Google Summer of Code is long gone or long over.
There's a full status report on that Mac policy for IP addresses in jails, the Mac IP ACL, which lists some of the things it can do, including the host can define one or more lists of IP addresses or subnets that the jail can use. The host can restrict the jail from setting certain IP addresses or prefixes. So you can say you can have anything except these. And you can also say the host can restrict the privilege to a few network interfaces. So you can make sure that they can only touch the interfaces they're supposed to be able to, and so on. Mm-hmm. And it includes a test suite. And there's more details on that in the report here. Then we have another one. Ed Mast and Mark Johnston worked on improving laptop support. So the FreeBSD Foundation would like to ensure that running FreeBSD on contemporary hardware, so especially laptops, remains viable. To that end, we plan to purchase the latest generation of one or more of a family of laptops preferred by members of the FreeBSD community. In this case, they purchased a 7th generation Lenovo X1 Carbon. And I think recently Mark Johnson did some commits to extend the Wi-Fi driver IWM to support the newer cards in that 7th gen 7th gen X1 Carbon. And so Ed now has working Wi-Fi on the newest laptop.
Oh, good. In case someone is in due need for an upgrade. The 7th generation. Because the 6th one is not being produced anymore. It's not available too much. So I guess it's the 7th generation you would have to get if you want to have the Lenovo laptop. Okay. Then we have updates for NFS. So NFS version 4.2 implementation is being worked on or has been worked on. Rick Macklem is the one that does this. So RFC 7862 describes a new minor revision to the NFS version 4 protocol. And this project implements this new minor version. And so what's in there? So this adds several optional features to NFS, such as support for seek_data and seek_whole, file copying done to the server that avoids data transfers over the wire, and supports for POSIX_fallocate, POSIX-fadvice. And hopefully these features can improve performance for certain applications. So this implementation in particular is now nearing completion, and recent work has been mostly testing. A cycle of interoperability testing with Linux has just been completed because it's a network file system. It needs to work on many systems using that. So the main area that still needs testing is use of the PNFS server, the parallel NFS, with NFS 4.2, and that should start soon. Once testing of PNFS is complete, Rick believes the code is ready to be incorporated into FreeBSD heads, in that current version. Testing by others would be appreciated, so the more things you can test, the more bugs you can find or report that it's working. The modified kernel can be found in the URL provided there and should run with a recent FreeBSD current system. And client mounts need the minor version =2 mount option to enable this protocol. Okay, then we have some update on embedded hardware. The Rockchip RK3392 SoC eMMC support has been done by Gunbolt Saganku, and that's our committer from Mongolia. The following features have been added to support that on FreeBSD. Extended simple MFD driver to expose a syscon interface, if that node is also compatible with syscon. And for instance, the rook chip RK339299 GRF, general register files, is now compatible with simple MFD as well as the syscon and has devices like USB 2, eMMC, and PCIe. And there's updates to general register file drivers to have a simple MFD driver. They added the driver to the rock chip eMMC PHY and added the eMMC support codes for the rock chip system on chip. Cool. All of the above was tested on a Nano PC-T4 board. There's updates on syscaller, which is basically a tool that helps uncover bugs.
Yeah, it's a syscall fuzzing.
So they found over a dozen kernel bugs fixed in the past 3 months and directly attributed to syscaller, so by just running that tool. And the number of syscaller reproducers have been incorporated into the test suite as well, so that they don't reappear suddenly without being tested first. And backtrace.io via Sami Albara, has graciously provided a large server for running a dedicated syscaller instance to fuzz FreeBSD under Beehive. So that's good. Thank you, backtrace.io. And though Sysbot, the public syscaller instance run by Google, already fuzzes FreeBSD, it has proven fruitful to run multiple syscaller instances. Since different instances run and find different bugs, and syscaller.backtrace.io allows us to experiment with FreeBSD-specific extensions. Very good. And yeah, they write, going forward, we will continue to extend syscaller coverage and make it simpler for users and developers to run private instances and optionally collect kernel crash information for debugging or for submission. So that's good. So you can test your newly written feature with the syscallers before sending it up into upstream.
A bunch of interesting bits in the kernel, including the new compare and swap stuff, which is mostly just performance improvements and implementing the in-kernel atomic operations on some of the other architectures. And then the really interesting one here is the kernel mapping protections. This is work by Mark Johnson. Modern CPUs have an ability to flag a region of memory as no execute, the NX bit, and it's been around for quite a while, which prevents the memory from being executed by the processor. So basically say, this memory is always going to be data. Don't ever run it, because if somebody's trying to run it, they've done a buffer overflow and are trying to execute their nasty code or something. NX mappings are an important security mitigations since they help segregate code and data, blocking the unintentional execution of memory whose content is controlled by an attacker. Then we have the WXORX, or write XOR execute, is a security policy which disallows the creation of mappings which are simultaneously writable and executable. Under this policy, memory whose contents can be modified must be mapped with that no execute bit. This policy makes it harder to exploit bugs that permit an attacker to arbitrarily overwrite data. So FreeBSD has long made use of the NX flag for user space mappings whenever possible, but only in the past several years has it been applied to parts of the kernel. A recent project has sought to implement a WXRX by default policy on the AMD 64 kernel by completing an audit of the remaining executable mappings in the kernel, making a modification to either apply the NX bit to those mappings or to make the mappings read-only so they can't, while they can be executed, they can't be written to. That work has since landed in head and is now available as part of FreeBSD 13 and will be part of 12.2. Similar work for other CPU architectures is also planned. And so to help audit the kernel mapping protections, a new sysctl, vm.pmap.kernel_maps, has added. It dumps a snapshot of the kernel's page table so that you can see which mappings are violating the write but not execute policy, so that you can easily discover and investigate each of those mappings. With a few rare exceptions, the only kernel mappings which require execute permissions are those of the kernel executable itself and local kernelable modules. The number of other regions of memory were unnecessarily being mapped without the NX bit, and these were identified and corrected. To address the kernel code mappings, the AMD 64 kernel linker scripts have modified to pad the text segment to a 2 megabyte boundary, because with the promotions to super pages, you don't want to have one super page that contains a little bit of both, because then it will not have the protection.
Sure.
To improve performance, the kernel creates super pages. I explain it. So enforcing write XOR X or execute turned out to be somewhat trickier. Unlike other CPU architectures supported by FreeBSD, AMD64 kernel modules are linked as relocatable object files or .o files rather than DSO files, as one might naively expect. The use of .o files means that the AMD64 kernel modules contain more efficient code, and they can be linked as than if they were linked as DSOs, and so on. As part of this project, an attempt was made to switch AMD64 to use DSOs as well, since the cost of this indirection can largely be mitigated with modern toolchains, but it was found that the use of DSOs would also force a change to the code model used when compiling AMD64 kernel code, resulting in a further performance penalty. So, not good to go. So the main obstacle with the use of the .o files is that sections are not page aligned by default. The segregation of sections with differing mapping protections is done by the static linker when linking a DSO or executable file. Since mapping protections are applied at the granularity of a page, that's 4 kilobytes on AMD64, the overlap of sections within a page cause problems since, for example, the end of a read-only text session may overlap with the beginning of a read-write data section, and so the whole page ends up having to be read-write. One possible solution is to perform any required section reordering and padding at kernel module load time, but this approach breaks debugging tools like dtrace and KGDB, which assume that the kernel linker does not modify the layout of the loadable modules. So as a result, the AMD64 kernel module linker scripts have been modified to insert the padding at compile time. And finally, the kernel linker was modified to restrict mapping protections based on section flags. So now they've added a bit of padding into the code to make sure that sections with different restrictions are separated so they land at different pages.
Okay, sounds great. Great work to have. And it's active, and people can, well, they don't have to do anything. It's there on all the AMD64 kernels. Yeah.
As a result of all this, AMD64 kernels now boot without any writable but also executable mappings. Though some of the work was architecture specific, much of it can be leveraged to provide the same policy for other supported architectures. And thanks to Netflix for sponsoring that project. And then Jin Lee and Yoshihiro Oto updated the version of Zlib that was part of FreeBSD and actually found a number of different copies of Zlib and unified them. So the Zlib is a compression library, basically is gzip. The FreeBSD system had used an ancient 20-year-old version of Zlib, version 1.0.4, and then 3 other copies. There was one for userland, one for ZFS, and one for the kernel. They updated Zlib to use the latest and eliminated the extra copies. Among the effects of this, Zlib is now version 1.2.11. NetGraphs PPP is re-implemented to use standard Zlib instead of its modified version. And we now only have one version of Zlib, and it's the latest, and it'll be easier to keep up to date. The new compress, compress2, and uncompress APIs have also been exposed in the kernel, and importing changes from Zlib in the future will be simple.
Mm-hmm. Excellent.
And they break down some of the changes, including removing support for gzip compressed kernel and loader, for gzip compressed a.out binaries, which went away with FreeBSD 3 or something, or 2, I forget. And MIPS Zlib elf trampoline has been removed.
So there's plenty more in the report. I just want to highlight one more item further down in the architecture section. FreeBSD support for the forthcoming ARM Morello CPU, system on chip, and board. In September 2019, ARM announced Morello, an experimental multi-core superscalar ARM v8-A CPU system on chip and prototype board extended to implement the Cherry protection model. So you know about Cherry, we've reported a couple of times about it, so this will implement this directly in the hardware. Morello will become available in 2021, and more details can be found on ARM's blog. They have linked that in the report, a light blue touch paper blog, and the main Cherry website. So they have updated Cherry BSD, a Cherry adapted version of FreeBSD, originally targeted at the MIPS-based SRI Cambridge Cherry processor prototype, to support the current draft architecture. So that will be ready when Morello launches. This includes full user space, spatial, and referential memory safety, called Cherry ABI, as well as backwards compatibility to support running existing ARM v8-A user space binaries. They will continue to update CherryBSD/Morello as the ISA is finalized. We'll also closely track the public CherryBSD/MIPS trunk. They pick up new software features utilizing Cherry as they mature, as well as to pick up changes from the baseline FreeBSD development trunk, of course. They currently anticipate releasing CherryBSD/Morello as open source once the ISA and toolchain are published in 2020. So you will hear more about this. This is just a little bit more looking into the future, what's coming. And FreeBSD is on this board, and we'll be very excited to have the support there once the hardware is available.
Yeah, and this work is sponsored by the Defense Advanced Research Project Agency and the Air Force Research Lab.
Mm-hmm. Yeah, so that's exciting. There's more in the report. We definitely recommend you start reading through all of it, or the sections that interest you that we didn't cover.
There's updates on fresh ports, Java, KDE, XFCE, and so on, and also some third-party projects like ClonOS, the FreeBSD ENA driver for Amazon, the Nomad pot driver, which is orchestration via jails, and the sysctl info command.
Good stuff all around, and thanks to all the people who not only wrote the reports but also worked on these projects and developments in the first place.
Yes, thanks to Edward and Daniel and everybody else who worked on actually compiling the status report as well.
If you have a status item for the next month or the next quarter, then definitely submit that. There's a GitHub pull request for that, and that should be easy enough for you to submit something.
Yes, they're trying to get these much more timely. So I think the current plan is to actually have it come out like as the quarter ends. So like in the second week of January, we'd like to have the one for the last 3 months out. Everything you've already done can be submitted now. And, stuff you do in January, or in December, you can submit then. Because it's been interesting for me sometimes when I've thought about the status report, I'm like, well, I know what I did last month and so on, but that's past the deadline. That's for the next report.
And it doesn't have to be fully completed. It can be work in progress where you ask people to test.
Well, yes, it's, one of the sections here is, hey, tell people about work in progress and get help finishing it.
You never know who's reading this and might spend some time working on some patches or testing stuff and report anything they find.
Yes, there's some interesting stuff on NFS 4.2 if you're into that. They could use some testing.
So plenty of reasons to get involved in this way. Could be your entry point into the project. All right, then next up in our news, we have OpenBSD on Spark 64. It's a blog post on erielinux.wordpress.com, and it starts with OpenBSD. Huh? Yes, the author here usually writes about FreeBSD, and that's in fact what the author tried installing on the machine first. But they ran into problems with it very early on, never even reached single-user mode, and put it aside for later. Since then, they powered up the Sunfire again last month and needed an OS now and chose OpenBSD for the simple reason that they have it available. Well, that's easy enough. First, they wanted to call this article simply OpenBSD on Spark, but that would have been misleading.
Because OpenBSD used to support 32-bit Spark as well. Mm-hmm. And so this was Spark 64. So they start out with OpenBSD 6.0 because that was the last version that actually came out on CD. When I bought it, I thought that I'd never use the Spark CD that came with it. But here's my chance. While it is an obsolete release, it comes with the cryptographic signatures to verify the next release. So the plan was to start at 6.0 that I can trust from these CDs with the signatures, then update to the latest release. This also has the opportunity to recap some of the things that have changed over the various versions between 6.0 and 6.5. So I had previously prepared the machine for installation, so I had to make a serial connection and everything was good to go. If you're in need of doing this and don't feel like reading the whole previous article, the important steps were attach the power, go to the lights out management system, issue the boot force command, then the power on command. At the OK prompt, you can set your environment boot-device to CD-ROM disk to set the boot order, and then set an alias for the CD-ROM device with env alias cd-rom to /PCI at blah, 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 IDE, blah, 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 cd-rom, blah, blah, blah. Big long string there. Then reset the machine with reset all, and then power on, and you will boot off the CD.
Huh.
And they have a screenshot here of OpenBSD 6.0 booting on the SPARC 64 machine with 1 gigabyte of memory.
Oh, yeah.
So OpenBSD's installation is very simple. Basically, an installation script that asks the user several questions, then goes ahead and does all the things that's required. Once that's done, on a casual installation, the script will ask for your keyboard layout. And since we're installing over serial here, that doesn't really matter. It asks for the kind of terminal instead. Since our CPU architecture is SPARC 64, OpenBSD assumes that we're using a Sun terminal. Well, I don't, so I chose Xterm instead. And of course, we need a host name. So they settled on Spaffy.
Because Spark and Puffy. Cool. That's original.
And set a root password, set up DHCP, and so on. Also set up SSH. So I don't have to use the serial connection all the time. Compared to many of the x86 servers, it's not as loud, but still quite a bit louder than you'd want on a machine sitting directly next to you for everyday use. And then allowing root over SSH is very bad practice, so I created a user next and disallowed remote root logins. Then they set up the partitioning, which is interesting because Sun's OS here uses VTOC, the virtual table of contents, its own custom partitioning scheme. Basically, the BSD partitioning and MBR partitioning were not expressive enough, and GPT didn't exist yet, so Sun did their own thing with VTOC. Then you say in the screenshot, OpenBSD's default partitioning is more complex than many people may be used to, but for good reason. Remember that you can mount file systems with different options. For example, you can mount your temp with no exec, and then make use of disabling WXRX everywhere except for user local for ports that you install, etc. Then you can select which packages or distributions you want to install, whether you want the man pages installed and so on. The man pages are tiny. You always want them.
Doesn't hurt, yeah.
Then he says, I have no use for the install RAM disk kernel or the multiprocessor kernel, as I don't need the system compiler or man pages and so on. And, if it's an old machine, you might actually be limited on disk space. So maybe that bit of savings is worth it. So once the installer is done, you can go back to the Lights Out management system and set your boot device to disk so that it doesn't try to boot off the CD when you reboot. And then once you reboot, you can log in as root, and you are now at the console of a fresh OpenBSD 6.0 machine. Then they go through the process of updating. Said, running a 3-year-old version of OpenBSD is probably not a great idea. So they wanted to upgrade to 6.1. So the first thing they did was fetch the RAM disk for the 6.1 kernel and its signature, and then verify that with Signify. And then once they did that, they could then do the upgrade option and upgrade the operating system, and then selected the HTTP location for the sets and point the installer at the mirror, and it will download that. And then once that's done, you can basically just keep repeating until you get up to the latest version. The newer versions also have a tool that will automatically look for newer firmware. In this case, probably because it's SPARC, that didn't happen, but it also takes care of things like merging the OpenSSH config file to, track the new changes. And then they update through the various versions, talking a little bit about the changes between each one. And finally, upgrade all the way to 6.5, which, as of this writing, was the most recent release, although 6.6 is coming out very soon.
All right. That seems straightforward enough.
So it had some interesting bits here. Because the Sunfire V100 is a server class machine, it doesn't even have a VGA port to connect a monitor to. It only has serial. But X11 could still be some use, just not necessarily for what you're used to.
For the more experimental type, this is probably a nice exercise.
So in a future post, they intend to explore the system a little and find out of what difficulties there might be on using SPARC 64 instead of something more common like AMD 64.
So it's time for the news roundup this week. We have this is basically the namesake for this episode. The ZFS on Linux repo moves to OpenZFS. Alan, tell us more about this.
So as we alluded to a little bit from the OpenZFS Developer Summit, now that the upstream repo for OpenZFS has switched from Illumos to Linux, or ZFS on Linux, it's not really Linux, that was fine. But then the FreeBSD project came along and ported that to work on FreeBSD and is working on upstreaming that. So very soon, the repo that used to be called ZFS on Linux will not be ZFS on Linux. It'll be ZFS on FreeBSD on Linux. And that's kind of a silly name. Lots of people wanted to call it Zoloff, ZFS on Linux on FreeBSD, but we said no. And so the repo will change its name to OpenZFS. And that will also facilitate additional operating systems being added to this repo. And it will actually bring the OpenZFS project, who, when it set out almost 10 years ago, with the goal of keeping ZFS the same on every operating system and making ZFS the file system you can rely on to move between OSs and so on. The original goal was to have this one common repo that contained all the ZFS code and can be compiled in user space and tested. And then each OS would maintain their glue to make that one common repo work. But nobody wanted to maintain that repo because it in itself was not useful, right? You'd still have to maintain your local repo that has all the glue to make it work with your OS. And so, that never really took off. Nobody was going to step up to do all this work to keep it working on multiple operating systems. But all the work would have to be done in other repos. And so for a long time, the OpenZFS repo was just a copy of Illumos that you could open ZFS-specific issues and pull requests against. But with this change where FreeBSD is upstreaming its glue to make it work with ZFS into the ZFS on Linux repo, we will now have an OpenZFS repo that is the common ZFS code and then subdirectory under OS, Linux, and FreeBSD that contains all the glue for those two OSs. And hopefully shortly, there'll be a third directory for OS 10. And then it should just go from there. And eventually, we will have this one repo that contains all the ZFS code, including the OS-specific bits.
Excellent.
And so that will result in a release of OpenZFS called OpenZFS 2.0, which will mean that if you know you have OpenZFS 2.0, you have exactly the same code, whether you're running it on FreeBSD or Linux. Because right now it's kind of confusing to know, I'm using ZFS on Ubuntu, so which features work here that don't work on FreeBSD, and which ones are on FreeBSD but not on Ubuntu yet? And then, what version of Ubuntu do you have? And it gets very confusing because you basically end up with the only version number you kind of had was the package version number on your Linux repo or the release version number on your FreeBSD OS. And this way we'll have an OpenZFS version number that will make sense.
Yeah, this is much more coordinated and long-term developments.
And one of the big parts of this is going to be coordinating the release of, say, OpenZFS 3.0 to try to hit the long-term support branches of FreeBSD, 13 and the next LTS of Ubuntu and CentOS or something. That's going to be some fun. But so in particular, the ZFS on Linux project itself is not going away. They're still maintaining their own website, mailing list, IRC channel, etc., for all the people that want to ask questions about running ZFS on Linux or whatever. And they will still release manage the releases that actually ship in Linux distros and so on. But the actual code repository will rename. So basically using the transfer ownership feature to move the repo ZFS on Linux into the repo OpenZFS that's already there and controlled by Matt Ahrens and so on. So far, they've tested that, and it preserves all the issues, pull requests, wikis, releases, labels, projects, Kanban boards, etc. So it takes care of creating forwarders for the old URLs. So even if you have like a git checkout or a git clone right now, it's still going to work. You're not going to have to do anything. It should just work. If anyone knows any drawbacks to this mechanism, hurry up and speak up before we run out of time and pull the trigger anyway. But the plan is for this change to happen before the end of the year. So basically, when you wake up in 2020, which is just a weird thing to say, there will be only one ZFS, and it will be great.
Yeah, to rule them all.
And the repo will fully support FreeBSD and Linux, and then hopefully OS X, and then hopefully also NetBSD and Illumos and everybody else. Someday the Windows one might get there.
Yes, and then we have the one file system for all the OSs out there.
More importantly, we'll have one repo.
That too, yeah.
For all, instead of different versions of ZFS.
Mm-hmm. And there's coordinated efforts and developments, and that's a big thing. And I guess that coming to this point here took a lot of efforts and coordination among different groups.
Yes. So huge thanks to Matt Ahrens and Brian Bellendorf for making all this happen and for just being great people to work with.
Excellent. Then next we have a Sun thread on Twitter by MCC. So she writes about her experiences at Sun Microsystems. It begins with, a long time ago, like 15 years ago, I worked at Sun Microsystems. The company was nearly dead at the time. It died a couple of years ago. And later, because they didn't make anything that anyone wanted to buy anymore. So they had a lot of strange ideas about how they'd make their comeback. So she heard a lot of high-ups there talk at the time about what Sun is going to be about over the next 10 years, quote unquote. They all seemed to have different ideas what that was. But the most common thing I heard was an idea they called utility computing that only seemed to exist within Sun.
Maybe it wasn't exactly what it was, but it sounds a lot like that is the cloud before the cloud. Different names,
same concept. So they thought in the future, no one would own a computer. Instead, your computer would exist in the cloud. Though that word didn't exist yet, as Alan mentioned. So ISP network operators, or the network operation centers, would have big mega computers, and you would just have a screen that would connect to the nearest NOC, and it would stream to you. Stadia, anyone? So you would have your computer desktop, but it wouldn't be a real computer running its own operating system. It would be just a user account on some server somewhere that stored your icons, and your data and your programs would all run on the server, and you'd pay a monthly bill. So Sun believed people would do this because if people did this, it would create business for the big iron servers Sun made at the time, and this way Sun would not go bankrupt. They didn't really have a user story there. They thought users would use Solaris. Nobody used Solaris even then.
So they say, so this never caught on as a product, but the thing is, they built this. It existed and it worked. When I worked at Sun, there was no desktop computers. Instead, every desk had a Sunblade on it. And they have a picture here. It kind of looks like a Nintendo Wii, although years before the Wii, and different colors and slightly weird. But anyway, every Sunblade had a monitor and a keyboard plugged in, and a slot on the front that took this credit card-like thing with a chip. Everyone who worked at Sun had a card clipped to their jeans, the same card you would use to unlock the doors of the building. You just stick it in, and then your desktop would show up. At the end of the day, you'd pull the card out and go home. And the next day, you come back and put the card in, and there were all your programs just where you left them. Even if the Sunray you put your card into wasn't the same one that you were using yesterday. So, the thin client concept. There's lots of these workstations all over. They don't really have much computing power. You log in and you access a big server somewhere that has all the computing power. Amazon was trying to do this for a while with a virtual desktop thing, where you'd use a thin client and connect and run your desktop in a VM in the cloud somewhere. Anyway, because nothing ran on the Sunblade or Sunray, it was just streaming window instructions from a big server at the center of the building. There was even some way you could go home and connect your computer and you'd be able to see your Sunray screen, just with a bit more delay. This was incredible, actually. It was magic. Sometimes you'd go to someone else's office to ask for help, and they would say, well, can you show me? And you would just stick your card in their Sunray, and instantly, there's your computer screen. It would even follow you upstairs. The way you do that in a modern workspace is everyone would have a MacBook, and then you went upstairs, you carry your MacBook, but in this awkward way. There's a 2-inch open so it doesn't go to sleep, and try not to walk into anything or anyone else carrying a laptop the same way, etc. Of course, there were problems. You couldn't do some things you'd expect to be able to do on a computer, like run a screensaver, because that would suck up the CPU. It only really worked for like writing documents and stuff, low animation stuff. Oh, and you had to run Solaris.
Oh, of course.
And of course, run Solaris just killed the whole thing instantly. So instantly, it baffles me how they didn't stop the project on day one. In 2004, nobody could use Linux except programmers. You struggled to run Office suites on Linux, and Solaris was one step harder than Linux. Still, they didn't kill the obviously unworkable project. They built it, whether anyone wanted it or not. And they replaced all their own computers with it. And I've never heard of anyone other than Sun using it. But for one summer, I got to use this awesome alien future tech. So why is it this interesting to me? Why did the Sunray fail? I think the answer is obvious, because they designed the product backwards. They didn't think, what do people want? Or even go Apple and think, what could people want if we showed them why they wanted it? Sun started with, what can we build? What would be good for us if people wanted it? And then assumed they'd figure out a way to work backwards somehow into convincing people that they wanted this and wanted to pay monthly for it and pay expensive sysadmins to use it and to use a 3-button mouse.
Yeah.
So obviously, I'm not really thinking about the Sunray here. I'm thinking about things like Google Stadia. Stadia is not a product that exists because people want it. I'm not sure why it exists, but it seems to exist because it could. Google knew how to make it, and it would be a good thing for Google if people wanted to use it. So they just made it and assumed the reason why would eventually show up. So Stadia is utility computing, but for games. But they don't have to call it that because we have words like in the cloud and streaming. It's a lot like the Sunray system, really. But if you try to compare Sunray to Stadia, I noticed something. Sunray actually solved problems that you might have had. The Sunray solved a problem. It had things it did better than the alternatives that existed at the time. It was made with a user in mind, even if that user, Sun Microsystems employees, were the same people making the Sunray. There was someone, me in 2004, it was great for. I do not know if I could say the same thing about Stadia. When I think about Stadia, I want to be afraid. I want to see it as one spike with Apple Arcade of an encroaching change that ends general computing and brings game creation under a publisher system, and so on. So there's lots more thoughts there and follow-ups in thread. So check it out. But I thought the story of what happened at Sun was interesting.
And looking back at it now, it's kind of, well, they should have known. But it's always, when you look backwards and be smarter than the people at that time. It didn't work out that way. For me personally, Stadia sounds too much like stevia, and it's kind of like, why is this, everyone's talking about this sweetener? But that might just be. So, we have another story from Mariusz Zaborski here on his blog about GEOM NOP. And I think he kind of wrote that because we mentioned it in the show. So thanks, Mariusz, for that. So he writes, sometimes while testing file systems or applications, you want to simulate some errors on the disk level. The first time I heard about this need was from Baptiste Darsin during his presentation at AsiaBSDCon 2016. He mentioned how they had built a test lab with it. The same need was recently discussed during the PGCon 2019 conference to test a Postgres instance. If you are a FreeBSD user, I have great news for you. There is a FreeBSD GEOM provider which allows you to simulate a failing device. GEOM NOP allows us to configure transparent providers from existing ones. The first interesting option of it is that we can slice the device into smaller pieces thanks to the offset option and stripe size. This allows us to observe how the data on the disk is changing. Let's assume that we want to observe the changes in the GPT table when the GPT flags are added to or removed. For example, the bootme flag, which are described here. We can use DD every time and analyze it using absolute values from the disk. To examine GPT, the offset may differ on your machine. We can use the following to analyze the GPT header. So he runs DD ifdef md0 with a count of 1, a skip of 1, and pipes that to hexdump-C to see his EFI partition part. With the following command, he can analyze the GPT partition array. So this is ddif def md0, count 1, skip 2, pipe that to hexdump-Z. And playing more with the block size count and skip values, we can get more detailed information about the GPT tables. What if we would like to observe them? So each time we would need to remember the absolute values of the GPT from the beginning of the disk. Thanks to the GEOM NOP provider, we can create a slice from the disk, and the new device will point to the interesting parts of the GPT table. So he does GEOM NOP create -o 512 -s 512 and defmd. The commands above create a new device, md0.nop. The device starts at a 512 offset, and its size is also 512 bytes. Thanks to that, we can use dd to read the data relative to the start of the GPT header. Unfortunately, at the time of writing, the limitation of this utility is that we can only create a single NOP device from a single provider. But this may change in the future. There's a link there.
Yeah, I was working with Marius and some other people reviewing to allow you to also specify a different name. So instead of it end up creating md0.nop, you could create md0. First 512 or whatever. You could name it in a different way so that you could have multiple of them at least.
Mm-hmm. Yeah, so there's something coming up the line, but now you can run it at least with one provider. Additionally, Marius writes, while creating it, we can configure how this transport layer should behave. One of the options is to configure the failure rate of the I/O request. So here it gets scary sometimes. GEOM NOP create -w 80-r60 defmd 0. So after using the command here, we created a new md0.nop. While using this provider, the probability that the write request will fail is 80% and 60% for the read ones. So, hopefully you don't have a disk like that. Some time ago, he also added 3 new options to simulate the slower I/O of the disk. We can configure the disk request delay and the probability rate of it happening. So, for example, I used to use it to test the behavior of a ZFS RAID Z2 when one of the disks is slower than the rest of them. So GEOM NOP create -x50 and -d1000 defmd0. While using a new md0.nop provider, the probability that the request will be delayed for 1 second is 50%. So, oh dear. GEOM NOP is very powerful, which allows you to test a failing disk, as well as a great tool for the disk forensics. You should have it in your toolbox. Yeah, thanks, Marius, for this nice blog post overview, and people should try it. Of course, not in production. If you really want to mess with people's heads, then, why is this I/O failing all the time? But for testing purposes and kind of seeing how things react, it's a good way of testing that. Very nice.
I remember looking at making a fake slow disk with it for Dan a while ago, although the way I did it was really bad, and it slowed all I/O on the whole system to the speed of the one disk you configured. Or rather, yeah, so because it held a lock while it was sleeping, it meant that when you wrote to that dice and it slowed itself down, while it was waiting for you to be allowed to do more I/O on that device, you couldn't do any I/O on the other devices, which was obviously not what you wanted.
Whoops.
Anyway, next up, we have keeping NetBSD up to date using package comp. So this is a tutorial that guides you through using the new package comp 2.0 on NetBSD. So the goal is to be able to use package comp to build a binary repository of all the packages you are interested in, to keep that repository fresh on a daily basis, and to use that repository with package in to maintain your NetBSD system and keep it up to date and secure. This tutorial is specifically targeted at NetBSD, but should work on other platforms that use package source. Except, at the very least, a macOS specific tutorial is soon as I create the package comp standalone installer for that platform. So anyway, you start by installing the sysutils sysbuild-user package and trigger a full build of NetBSD so that you get usable release sets for package comp. So I guess this has actually got some package basey type stuff on it.
Could be, yeah.
Alternatively, you can download the release sets from FTP and tell package comp to just use those. So sounds a little Poudriere-y as well.
Poudriere-ish.
Then you can install the package comp-cron package, which I'm guessing triggers this automatically. So to use package comp for periodic builds, you'll need to do some minimal edits to the default configuration file, and it discusses those. And they have a sample configuration file saying, here's a list of packages that you need. Here's the CVS route to get NetBSD from, which tag you want if you're going for a specific version, where you should put the files when it's done, etc., etc. Now, building your own packages by hand, you can just basically run package comp -c, pass over the config file, auto, and it will start building everything. So it'll check out or update your copy of package source. It will create a sandbox. It will bootstrap package source and pbulk in that sandbox, then use pbulk to build all the packages you've specified in your config file, and then finally clean up the sandbox when it's done. After a successful invocation, you'll be left with a collection of packages in the directory you specified in the config file, which defaults to var package comp/packages. If you'd like to restrict the set of packages to build during this manually triggered build, you can also provide extra arguments. So you can say, just do this, or you can also specify individual steps. So if you just want to run package comp fetch, it will download all the requirements, but not actually do anything, which you might want to do ahead of time. Or you might want to cron the fetching step, but not necessarily the building step or anything like that. Anyway, once you have a set of packages, it's time to update. So now that you have built your first set of packages, you want to install them. On NetBSD, the default package comp cron configuration produces a set of packages, so you have to wipe your existing packages first to avoid any build mismatches. So warning, yes, you really have to wipe your packages. Package comp currently does not recognize the package tools that ship with the NetBSD-based system. It bootstraps package source unconditionally, including bmake, which means that the newly built packages won't be compatible with ones you already have. So they recommend using package_delete -lowercase r, uppercase R star to basically remove every package. And then even moving your user package etc directory somewhere out of the way, and deleting your user package and user database package directories. Now you can bootstrap package source and set it up, and then you're good to go. So you specify the path for your repository into your etc package_in repositories.conf. Then you just do package_in update and package_in upgrade, and it will keep you up to date.
Yeah, seems like a nice way of getting the latest and greatest stuff.
Mm-hmm.
All right, time for the news. The newest Beastie Bits here in this section of the show. We have Dragonfly with Radeon improvements. That's a commit here from Francois Tijon. And it's a DRM update generic TTM Radeon code to Linux 4.9. So they're on parity with that at least. Generally clean up non-driver specific code and increase its robustness. They have DisplayPort support improvements, atomic mode setting improvements, as well as Radeon performance and stability improvements. And so DRM i915 stays based on Linux 4.7.10 with Linux 4.19 changes for now. Excellent, so that people can enjoy latest graphics on Dragonfly as well, or at least a bit more fresher versions. Then we have a NetBSD review on YouTube, so you can watch that if you haven't too much of a clue what NetBSD is or how it looks like. That's an interesting video or introduction to NetBSD. And then we found a SpongeBob OpenBSD security comic. That's interesting. Of course, this is just, it's not just a PNG, but it's kind of like from a meme generator put together. And it's kind of difficult to describe because it's just audio only. But if the people are interested in that, you can click the link in our show notes. Then we have Forth, the early years, over at ColorForth on GitHub. And this gives us an interesting look into the way of Forth, the early years. So you can get a little bit of a feel how it was developed and where it started, as well as the syntax. And you can definitely see that this is a bit more difficult to read than nowadays code, I guess. But it shows a nice way of, how it evolved over the years from the, where did it start? 1958, and then there's a version in 1961. as well as newerish versions. 1971 got some more stuff, and it's definitely a good read into a language that's maybe a bit extinct nowadays, but nevertheless it was important during its time and has some interesting syntax that other programming languages also based on.
It's definitely got a history.
Yeah, sure.
I'm mostly glad I don't have to use it, because every time I look at it, it makes me make my head hurt.
It's not for the faint of heart. Yeah. So the last item we have here is also another YouTube video. It's LCM plus L, the PDP-7 booting and running Unix version 0. So that's interesting for the historians.
Yeah, so that's part of a history project where they actually managed to grab one of these old machines and get version 0 running again. It kind of reminds me of, I was recently watching a short documentary on YouTube about, what was the name of the spacecraft before Voyager that went to the edge of the solar system?
Yeah.
I forget the name. Anyway, that NASA had to keep a PDP-11 working to be able to keep sending it instructions.
Yeah.
Because, that's what they built it on originally. And so they had to keep one of them around so they could continue to send it instructions. Now it's a combination of, I think, so far away and so low in power that we can't receive its transmissions anymore.
Leaving the solar system and coming back to this show, well, we're kind of into it. It's feedback and questions time this week. As always, send us anything that you find interesting to have in the show, whether it's comments, show ideas, topics, or questions like the people we have here today. Send all of this to feedback@bsdnow.tv, and then this section will not be empty. The first one is Chris about Control-T, which we all know and love on the BSDs. So he writes, hey guys, thanks as always for doing the show. Oh, you're welcome. Can you discuss what happens when a user presses Control plus T on FreeBSD? Could you maybe also discuss why it also works in NetBSD but not OpenBSD? Thanks.
I wasn't aware it didn't work on OpenBSD. I'm pretty sure it does.
Maybe not everywhere.
Maybe not everywhere. But I'm pretty sure it does work on OpenBSD, but I could be wrong. I don't have much recent experience with OpenBSD. So when you press Control-T, there's two different things that happen. The one is that the operating system outputs a line kind of telling you what's going on. And then it also raises sig info for the process. And the process can receive that and give more information. So if, for example, you're running, say, DD, and it's running and it's just sitting there, you're like, what's it doing? You press Control-T and it outputs a line, and it tells you the current load average of the system, the command that's running. Currently it's DD, but if you're running a shell script, the shell script might have called some other command and it's waiting for that command to finish. So pressing Control-T tells you which command, and then it's PID that's actually the controlling process at the moment. Then in square brackets, it tells you what the current kernel state of that process is. So it could be running, meaning that that program's doing something right now and you should expect results someday. Or it could be something like pipe RD, meaning that program is currently waiting to read from a pipe, meaning that that program is waiting for some other program to write something to the pipe before it can do anything. So, if you're piping something into grep and you press Control-T, you might see that grep is waiting for some input on the pipe so it can filter it for you. Or you might see, ZFS IOCV, meaning that ZFS is currently waiting for the IO conditional variable. Basically, ZFS has asked the disk for some data or to read or write some data, and it's waiting for that to be finished. BIO RD or RW, meaning basic read or write. Or you could say sleeping, right? If you just run sleep 10 and then Control-T, you can see it says sleep and it's currently in nanosleep, sleeping for a billionth of a second or whatever. Then the rest of the line tells you how much runtime that process is used, how much user time, system time, the current percent CPU time, and the current resident memory.
That's very useful.
Now, most programs on BSD will also see that sig info and give you some additional information. So for example, sleep says sleep, about 8 seconds left out of the original 10. So it tells you how long you're sleeping for and how much time is left in the sleep. Or DD will print how many records have gone in and out, and usually say X bytes transferred in Y seconds at Z speed. Or CP or MV will tell you the name of the file it's currently doing, right? If you're moving a whole directory, if you keep pressing Control-T, you'll see each different file being copied, and you can maybe from that guess how far through you are. Or if you're copying a file, Control-T will even say, I'm 37% done this one file.
Or if you're using TCP dump, it will show you what kind of packages or how many packages were already captured on BSD. If you want to know more about these signals, there's a man page. There's man signals. So be careful there. Not all the systems or not all the Unixes have the same number of signals or different implementations of signals. So that's why the BSDs have Control-T and some others never have that or haven't implemented that.
Right. Yes. On Linux, I don't think there's sig info is not defined, and then that leads to sadness. But macOS does have it as well. 'Cause I remember when Jorgen added Control-T support to ZFS send so that it would output some additional stuff.
And if you're writing shell scripts, you can tell your shell script to react to this by setting a trap, basically, for this event to occur or the signal being sent to your shell script. And then you can write a subroutine or like a function to say what should happen when that signal is received. And then you could output some information about your shell script, for example. So that's a nice exercise. So you can Google for shell scripts and then signal handlers and traps. That will give you the pointers to do this. Yeah, hopefully that answers your question. And we think that's a cool functionality.
Control-T currently seems like the greatest thing since sliced bread, right?
Surely.
But then Conrad and some of the people at NetApp have invented sliced bread with Nutella on it. So he has a little video here where you can see Control-T that in addition to printing that one line from the kernel and the lines from the application, also prints out the current kernel stack trace. So, you can see that currently, so in his example here, he's running sleep 5. You can see currently it's in the nano sleep state. But looking at this, you can see that it's actually, done the syscall and it's in user clock nano sleep and then and so on. So in addition to just knowing what state the process is in, you could actually see what set of function calls in the kernel it's gone through to get there, which might help you figure out where it's stuck, if it is stuck, and so on. And for them in OneFS, they have an even crazier version that extends Python. So it prints out the Python user space stack as well. So that you can actually tell what function you're currently running in the Python code.
Where am I? Yeah.
Well, that would get upstreamed into Python, probably not FreeBSD, but that could be really cool.
So yeah, there's also improvements in that area. And maybe if you're writing a program, then you could already think about how to, support Control-T for the people who have that functionality. All right, next up is Brian with a question about migrating Nexenta Store to FreeBSD and FreeNAS. Brian writes, "Greetings, guys. Here's another ZFS question for you. I have a Supermicro-based storage server running an older version of Nexenta Store that I would like to migrate to FreeNAS. It has the OS on a mirrored pair of 2 drives, or 2.5. And a data pool on a separate set of drives. My thought was to pull the existing boot drives and replace them with a new drive and install FreeNAS or FreeBSD on those. Is it possible to do this without having to destroy the existing data pool on the other drives and rebuilding it, but just manually import it into FreeNAS after the install?"
The answer is yes, because that's what's amazing about ZFS. Basically, as long as the thing you're converting to isn't too much newer than the thing you're converting to, it'll work. And since the Nexenta one will be quite a bit behind, it probably should work. I don't know if Nexenta has any of their own features that are not open source. That might pose a problem, but I don't think so. And so in that case, then yes, it's just Illumos, which FreeBSD is at least as up to date as, meaning that you will just be able to import the pool and it will work. You'll probably even have the option to run zpool upgrade to enable newer features. Just remember that once you do, you won't be able to go back to Nexenta Store.
Yeah, so this is a one-way street.
But yes, in general, it should just work. That's the beauty of ZFS.
Yep. And I guess you kind of saw that already with running that Nexenta store for a while. And yeah, definitely checking out that on FreeNAS. And once you're there, you can use all their features that they provide.
And yes, I definitely feel your pain about not wanting to move 40 terabytes of data.
If you can avoid that, yeah.
I've got a couple hundreds of terabytes, and yes, that would be unfun.
Yeah.
And so yes, you should be able to do that. You can even just confirm it before you do any of this by booting the FreeBSD installer memory stick. Just stick it in the machine, boot it up, and then drop to the shell and just do zpool import, and it should see it. And you can do zpool import $R/MNT, and then the pool name, and it should mount it under /MNT, and you should be able to just see if it works. You'll be able to find out basically in a couple of minutes without having to actually open the hardware even. But mostly, yes, it should just work. There shouldn't be any problems.
And if you've done that, maybe you want to write that up in a nice blog post so other people can see that it works and how your experience was.
Yeah, like I know Baptiste switched a whole bunch of hardware at Gandhi from Nexenta to FreeBSD. Although I don't know if they just imported the existing pools, but I imagine so.
Yeah, I guess there's a number of people out there on the web that have done this already or have written about that.
But yes, the really nice thing with ZFS is you can just do this. And the other thing is that you could also, in a different situation, pull the hard drives and stick them in a different machine and it would work. Whereas with most hardware RAID controllers, that wouldn't work.
Yeah. So that's you're very compatible into the future. And so that's a good way to move data around without doing too much of the copying. So hopefully that gets done well and you have the new FreeNAS from previous Nexenta store.
Yeah, if you have any trouble, do let us know.
Last in this week is Avery with the question, how to get involved. So Avery writes, "Hi Alan and Benedict. I've been listening to the show for nearly 2 years now. Wow, great. Hopefully not continuously. You did do something else in between, right?" Okay, so, and have just started listening to the back catalog. Despite using mostly Linux-based operating systems, the BSD have always been very interesting to me. Since I've started using FreeBSD more and more lately, I've been feeling a strong drive to get involved and contribute back to the codebase and community, but I don't know how to get started. Any advice would be greatly appreciated.
I think my biggest advice is find an area you're interested in. Because when you're doing volunteer work, it turns out motivation is the hardest thing to come up with. Even if it's an area you don't have much experience in and you're not very good at, you can learn. In order for that to work, you have to want to do it. There's a bunch of areas of FreeBSD I'd love to help out with, but I just don't have the energy and motivation. And so, kind of the great thing about these open source communities is you can work on the thing that excites you. When I was working on the bootloader stuff, if I hadn't been really motivated and really wanted to figure it out, I would have given up about 300 separate times.
Yeah, there's a lot of frustrations there, and you kind of get stuck sometimes. And hopefully, you have people like on IRC that can answer your questions, and people are there actually to help you and are friendly enough to answer your questions, even though you think these might seem dumb. But they aren't. They are just beginner questions. That's perfectly normal. They all started this way. They just want to not confirm that sometimes. There's stuff in the bug tracker, for example, or if you want to have some low-hanging fruits, maybe you can scan the FreeBSD handbook for any typos or broken links. Maybe that's small things like that gets you.
Yeah, starting in the bug tracker can be really demotivating right away.
Sure, because it looks like everything's broken and nothing works.
Well, not just that, but like even when we've done that hackathons and so on, and just trying to go through the bug tracker, a lot of times it's like, yeah, it turns out most of the ones that are open are because there's something sticky, maybe not obvious at first, but yeah. So I would say definitely find, what your interests are and find something that fits there. The project can use extra people in pretty much every dimension. So whatever you're most interested and excited about is probably the area where you will be able to keep going the most.
Yeah, but you're not limited to this area. I mean, Alan started in documentation and...
I put my fingers everywhere.
Yeah, sometimes you are involved in too many things then, but that's the good thing, that you can switch between things and there's no one like, oh, you need to deliver this now, and it's kind of like late already. And of course, we also want to have work submitted in a timely fashion, but like this, we're not bossing people around this way. So
yeah, you're a volunteer, so we get what we get. Like I started with docs, and then I did a little bit of user space stuff and messing with ifconfig and libxo and UCL. And then I was like, oh, I'm going to do bootloader stuff. And then it's like, oh, let's do some crypto stuff. And then let's do the next thing and the next thing. I don't think I've ever stayed in one place very long, other than, always having my fingers in the ZFS code.
Yeah, that's your constant there. But it doesn't have to be code. It could also be helping, as I said, in the documentation area, or porting, taking care of a port that's been abandoned or needs a bit of upgrades. That also is a nice way of contributing back to the project. And people are usually very helpful to newbies and want to bring them up to speed so that they can contribute and provide. Because chances are the thing that you start with is not the last thing that you're working on, and before you know, you're pretty productive and start, oh, I could do this other thing as well, and then it takes a life on its own. But you can also say, I just update this port occasionally and then disappear into the void again until there's time for a next update. So plenty of opportunities. Let us know how your journey goes. Definitely reach out if you find us somewhere on IRC or on the mailing lists maybe. And then, we'll try to be helpful.
Yeah, so whatever excites you, whether that's just creating tutorials on the forums and stuff, or I think one of the recent projects that a student was working on was the ext4 file system driver, or whatever it is. The one we covered earlier was Marius extending the GEOM NOP system to be able to create arbitrary views of a disk.
Or like me, the other day, I was like running BECTL and I was switching between boot environments, and I was like, yeah, it's nice, but why is this message lowercase? It's always beginning with lowercase. So I looked at the source code, I created a patch to make these look uppercase, and then there's other instances where messages that are shown to the user are lowercase, starting with a lowercase letter. And I'm like, I want to have this in an uppercase. And so it's not a very helpful patch, but it's more eye candy this way.
Have you sent that to Kyle?
And he approved that. And so I just need to commit that. And so it's just a small thing, but now I looked more, I saw the code, and maybe I find some other stuff there, or I get more familiar with the code. So a small thing like that could lead to a much bigger improvement down the road. Okay, so hopefully you got a couple pointers, and definitely help us out in some areas we are always in need for good, new, fresh blood people wanting to help. All right, that pretty much wraps up this week's episode. Thank you for listening. As always, safe drive for the people who are listening to us on their commutes, if you're driving yourself, that is. And have a nice week, and see you next time.